Hello, welcome to this video. This is 10-1 and we are talking properties of logarithms. All right, and we are going to utilize these properties when we're solving equations involving logarithms. This will be important especially next year when you take AP Calculus, and even if you're in AP Calculus going back watching this video. These are very, very important. Okay, so we're going to go ahead and talk about the properties at hand, and that's our objective, to get to know these properties and utilize them. So here the properties are valid for logarithms of all valid base values, and this includes specifically the common log and the natural log of x. Now for any positive numbers of, in this case our variables are a, m, and b, the base b cannot be 1, and C, when we're talking about change of base property, that also cannot be 1. So here are the following properties. We have the power property of logarithms. Now this one we're generally going to utilize first when we are compacting or solving logarithms. If we have a coefficient, we can move it up into the argument, or vice versa. If you're expanding a logarithm, you can take down a exponent and then put it out in front. And that helps when you're kind of solving logarithms. Second is the product and quotient property of logarithms. Now these properties are similar, and it's important to note kind of the order of how this goes, because the operations cannot switch places. Like it's not true for vice versa. So let me tell you what I'm talking about. If I have log base b of an argument plus log base b of another argument, I'm adding those. They're the same logarithmic base. I can combine those two logarithms into one logarithm to be log base b of m times n. So you multiply. So if you're adding two logarithms, you can combine them into one and you multiply the arguments. Now same with the quotient property, right? I'm subtracting, taking the difference of the same logarithmic base. I can combine them into one logarithm and I divide those arguments, right? So again, it's important to note the first minus the second, right? So the first one is on top. So m minus n would be m divided by n, right? Inside of those logarithms. Okay, so that's, oh, and what I was talking about, you can't switch them. So like if I have log base b of m divided by, like imagine, don't write this down, but imagine, okay, if that's a division sign of log base b of the n, I can't combine those into one logarithm and just subtract the arguments. It doesn't work the other way around, okay? So important to note. All right, definition-based properties, these ones are important. We're going to utilize these when we simplify, but just note, here's kind of like the, I don't know, the identity property. We have log base b of b. Well, that just simplifies into being 1, right? They're inverse functions, an exponential and a logarithm. Now, if I have log base b of 1, that is just 0. Okay, so, and that's kind of like your x-intercept. If you imagine the exponential function, right? Or I guess this way, or a logarithmic function, right? The intercept is at 1. Okay, so the output is 0. And then log base b of b to the power of m. This follows from our power property. I can bring down that m in front, and then utilizing here our first definition-based property, that gives us m. One property that we won't utilize today, but it's a property that we will utilize in calculus, the change of base property. If I have log base c of a, and I don't really like base c, I mean, if I have a TI 30 and I can't evaluate that logarithm, then like say it's like base 3. Random base, okay? You can go ahead and switch out of that, and you can make it whatever log base you want, right? So we would switch to something like the common log or the natural log, and it's just log base b of a divided by log base b of c. All right, let's go ahead, and now I've spent 4 minutes talking about those properties. Whew, I recommend flashcards, do flashcards. Let's look at some examples. All right, so here is the first example. And it says, use the properties of logarithms to simplify as much as possible. Show your work. And what I want to direct your attention to right above me is kind of this order up here. I wrote step 1, where am I? Right here. Use the power property first, okay? And so what I'm going to do is I want to move any like coefficients up into the numerator. So this is going to be the power property. I want to make sure I have my, okay, my correct ink color. So I have log of 16 to the power of 1/2 plus log of 5 to the power of 2. right? So all I did was take those coefficients and move them up. Again, that is the power property of logarithms. Okay, now what I'm going to go ahead and do, I'm just going to kind of simplify this, kind of clean house. 16 to the power 1/2 is 4. So log base 10 of 4 plus log base 10 of 5 squared is 25. Okay, well, now I'm going to go ahead and use the product property. I'm adding two logarithms. It's the same base. It's the common log. They both are, right? So step 2 right here, right? Product property. I can go ahead. I can combine those. So I look at those first. Log of 4 times 25. And this happens to be log of 100. Hey, we're done. No, you thought. What's the base? It's base 10. So here's where we're going to use one of our definition base. I'm going to go ahead and rewrite. I'll write down in the base 10, but we know 100 is 10 squared. Okay, so big whoop. Well, now I have that log base b of b. So these two, right, the log base and the exponential, they cancel out. Okay, so this gives us 2, and that is that third definition-based property that we have here. Okay, and this is our answer here. Hey, not too bad. All right, here's the next example. Use the properties of logarithms to simplify as much as possible. Show your work. Okay, we gotta show our work. So, do I have any powers in front to use the power property? Like any coefficients? No, nothing goes up. Okay, so I have the same base and I'm subtracting. Well, that is the quotient property, right? So I can go ahead and rewrite these as one base. So this is log base 3 of, okay, so top, right, divided by the bottom. So the first minus the second, that becomes the top. The second one becomes bottom. And I can go ahead and reduce this. They're both divisible by 27, so that gives us 1/3. And hey, can't I rewrite 1/3 as 3 to the power of -1? Oh, yes, I can. So our answer is -1. That's it. Not too bad. Not too bad. All right, so here's some practice problems. Please pause the video. I want you to try this, and I'll go ahead and show you the answer. All right, so hopefully you have tried this. Here's the solution. And you should have gotten 2. The answer is 2, right? So when you multiply these, you have 625 over 25. Well, that just ends up being 25. And then 5 squared, that's 2. All right, here's the next practice problem. Again, please pause. Try this one. Ooh, this one's good. All right, hopefully you tried it. And your answer is, drumroll, -2. Did you get it? Good job. Proud of you. You've got this. This isn't bad. All right. Next example. Ooh, ln. I had a professor in college called Lin. Lin of 10 plus 3 ln of 2. Oh, it's telling me I gotta hurry. My computer's gonna die. Okay, so we're gonna go ahead and first use our power property, right? So step 1, power property. Okay, so I have the natural log of 10 plus the natural log of 2 cubed, which I can go ahead and simplify to be the natural log of 8. If you're wondering like why I'm putting in parentheses and sometimes I'm not, I mean, sometimes logarithms don't have them. Sometimes it helps you understand like what the argument is. The natural log of 10 times 8, okay, which is 80. Natural log of 80. Okay, and again, the second one that I'm going to utilize is the product property, right? Same base. I can go ahead and combine those two logarithms that are adding into one. So natural log of 80, and that is our answer, right? Because 80, I can't rewrite the natural log, which is base e. I can't rewrite 80 as base e. So that's our answer. Okay. Here is the fourth example. Please write this one down. And this one, whoo, there's a lot going on. We're going to go ahead and first use the power property. So I'll show you that. Then we're going to use our product property. I'm going to combine with adding, and then our quotient property, right? If you see that subtraction. So here's the power property, right? I have a 4. I'm going to bring it up into the power up here. The 1/3, I'll bring it up here. And I don't have any for the third term. So we get log base 4 of 2 to the 4th plus log base 4 of 27 to the 1/3 power minus log base 4 of 6. Okay, well, 2 to the 4th, that's 16. So I have log base 4 of 16, and 27 to the 1/3 power, that's just 3. And notice I'm adding these, right? So can't I combine these? I'm going to multiply them, right? So 27 to the 1/3 power, that's 3. Log base 4 of 6. Okay, and now I'm subtracting, right, the same base, so I can go ahead and divide the arguments. So log of base 4, what's 16 times 3? 48. Good job. Divided by 6. Okay, which gives us log base 4 of 8. And you're like, hey, I can't rewrite 8 as base 4. You're correct, but what I can do is I can use a little trick that we learned in the last unit. I can set this equal to y. I can rewrite this as an exponential form, so 4 to the power of y equals 8. Well, this is 2 to the power of 2y is equal to 2 to the power of 3. Thus, 2y is equal to 3 by the exponential property of equality, and y is equal to 3/2. Okay, what does that mean? Well, it means that this logarithm is 3/2. So all of this is equal to 3/2. There's your answer. Do we have to do that? Yes. If you can go ahead and solve it, then you're going to have to do that, okay? All right, that is it. That's all I have for you. Here's some practice problems. Please pause the video. I want you to try this one, and I will post the solutions. All right, so hopefully you paused it. Here is the answer. 0, nothing. Can you believe all that? It's nothing. It's gone, nothing, right? Natural log of 1. Maybe you got that, and you're like, oh, I can't rewrite 1 as base e. Well, natural log of 1, any logarithm evaluated at 1 is 0. Here is the next practice problem. Please pause the video. Try this one. Okay, and here is the solution. Okay, the 2/3, don't be confused by that, right? You're just taking the cubic root of 8, which is 2, and then 2 squared. That gives you the 4 right here. All right, and then here is the last practice problem. Hopefully you pause the video, and here is the solution. All right, so I hope what you found out in these problems is that there's kind of a general pattern. The first thing that you're going to do to simplify these, you're going to utilize the power property, step 1, right here, okay? And you're going to bring up any coefficients into the argument and treat it as a power. Then if I'm adding any logarithms, I'll put them together so everything's, right, as one term by being multiplied. And then if we have to subtract, we'll utilize the quotient property. Okay, that is properties of logarithms. Hopefully you know them. Hopefully you can use them. Catch you next time. Peace.